Let's get started. Hi, everybody. Welcome to the resumption of the Open Game Data Open Office Hours for spring semester and possibly going forward from here. And I just want to do a brief intro on what these sessions are before we hand it off to Jimmy, who's going to be our presenter for this week. So the Open Game Data community is this NSF-funded research incubator that Dave and I and Magy Seif El-Nasr are taking the lead on, where the goal here is to bring together a collective of researchers who are interested in using data generated in and around games to advance our scientific understanding of thinking, learning, decision-making, psychology, humans in general. And so we have a couple different primary goals here. So one is to compile resources, best practices, and thoughts about how we do this. And that's one of the reasons, it's one of the things this Open Game Data Open Office Hours system is great for. And then eventually the goal will be to build actual technical infrastructure to help facilitate this kind of best practice across the field. And so we have a bunch of different resources, which you can check out when you get a chance. So the Open Game Data website is kind of where it's kind of the core of the project right now, largely running out of field day. But we're looking to expand that and integrate more games as time goes on. We also have the Slack where we coordinate these open office hour sessions, and then anybody who's interested in being involved in the project. And I will drop a link to that in the chat. And then we have these open office hour sessions, which you're joining now. But then we'll be going bi-weekly for the foreseeable future, at least to the end of the spring semester. And then maybe shift to a different date after that. But the goal is to keep them regularly going. So how do these sessions work? So this open hour session format is based on a series of workshops that used to happen at Carnegie Mellon's Statistical Education Research Group, where usually a student, or could be a postdoc, could be another faculty, would come, they'd present on a project they were currently working on, and they would do it with like, here is my Jupyter notebook, or here is my RStudio, or whatever at the time. Here's all the things I'm doing, here's what I've done, here's what I think it means. And then they would just workshop with the statistics faculty publicly of like, well, have you thought about this? Or what are you really trying to do? Or maybe if you did it differently. And it was a really useful resource when I was a student to sit in that room and just be like, this is how experts think about this stuff. So that's kind of the goal of what we're trying to do here is we'll bring in a bunch of different speakers. They'll present on something they're doing, something they've done, and then kind of get some dialogue with the community and see what they might think about doing next. And so sessions are recorded so that they can become part of this library that other people can use going forward. So some quick things to keep in mind. So presenters are often showing work that is in progress. So you want to be thinking about that and considering that it can take courage sometimes to show off something that's not yet done. And that you can kind of expect analyses potentially to be rough or in progress, or things that are being worked on or still worked out. And our goal here is to help the presenter achieve their goal. So whatever that goal is, help them think about what to do next, how to consider their problem, and accomplish whatever they're trying to do. You might come up with some really cool new ideas that are in the space of their project, and if you want to follow up on those after the fact, that would be great. But our goal here is to try and help them make progress. And then these sessions are about learning for everyone involved. So you as an audience, as well as our presenter, if you have a particular insight or something you think would be really helpful, you can raise it. Just raise your hand. I will kind of facilitate an MC. But also, if there's something somebody said, some technical jargon or whatever that you don't really understand, you can also raise your hand and say, "Can you please explain that?" And then we can dig into details there. And with that, I will hand it off to Jimmy, and you should hopefully be able to share and all that. And I will also mute myself.
Sure. Thank you very much, Eric, for the explanation. And let me see. I would share my screen now. So I suppose you're able to see my screen. Great. Okay, I'll put the chat here. Okay, give me 1 sec. There's a lot of Zoom component on the screen. I need to move. Okay. Sure. Okay. Thank you very much, everyone. So I'm Zhao Qing, and you can call me Jimmy. I come from a GUI lab, UC University of California, Santa Cruz. And I'm a fourth-year PhD candidate under Magy's advice. So today I'm going to present a system I'm working on. It's called Inspect. So it's an interactive system to analyze player journey maps. Okay, so the first of all, what is a journey map? So player journey map is an interactive node edge visual representation that are helping to understand player experience. So on the graph, you can see here is a part of the journey map we have. The nodes are representing the player actions or activities. And the edges are representing player transitions between players' actions or activities. So the nodes are color-coded based on the absolute visits, and the width of the edges also represent a similar idea. So here, there's two concepts I want to mention. One is a user visits, and one is absolute visits. So the user visits is count the individual users or players, and the absolute visits is like the total number of visits. Because like one players may visit the node for multiple times, so I have this like two different concepts for understanding player experience. Before I jump into the system, I would like to introduce the two data sets I'm going to use today. So I give you a basic impression of what are these two data sets describing. So the first one is a VPEL dataset. So VPEL is a RPG game that are a mod of the Fallout, I think Las Vegas. And this is screenshots or of the dataset. So we have a multiple column called activity, user ID, start time, end time, location quest, and some demographic information that are predefined in the dataset. So all of this field are required to as a format of the data if we want to use a system. And yes, this is the first one, which is RPG game. And we focus on the activity around the quest of the game. So in this game, players are required to complete like multiple quests to progress the game. So we filter out other activities, and only this quest related data are remaining in the data set. So we want to understand like how players complete each quest and how they move between quests, something like this. So the second data set, I think if you are here before, I think last quarter, Johannes introduced his system of the collecting data Guild Wars 2. The second data set is generated from him. So this is the skill data that player use in the game Guild Wars 2. So our system visualizes skills as an image, so which can instantly telling users like what the player did in the game. So this is a screenshot of that. Okay, so this project is, the Inspect system is to build some or construct some features that can help users to understand, interact with this player journey maps to understand player experience. So in the following, I will introduce several interactions or features that I have built in the system. So to better explain it, I would rather like show it in the system. So I will have slides here, introduce the feature, and then I will show the real, like how you use the features in the system. So the first feature is the segmentation. So the motivation of this feature is like the player journey map can be very messy. So it's cluttered. So there are a lot of nodes and edge on the graph. So we want to clean it up, have a filter out like less important or less interested patterns to avoid messy player journey maps. So there are like two different segmentations we implemented. The first one is a demographic, or we call it metadata segmentation now. So it's a pre-configuration of the data set. You have different fields as a column in the data set. And there also, we can use like player-specific information or action-specific information. So for player-specific information, it can be demographic information such as gender, age. It can be also like self-reported expertise level, something like this. For action-specific information, it can be like which quest this action belongs to, or which location it's happening, something like this. So this is the first segmentation, and the second one is a behavioral segmentation. So this is more like segmenting players based on the selection of selections of nodes or edges on the graph. So for better explain this, I will show this. I assume you are able to see this, the system. So this is the inspect system. So we use WebHel data at first. So you can see like this is a original player journey map. So there are like fundamental filtering or operation or manipulation of the graph, of course. So you can filter out like less important nodes or edges that only like nodes are visited by a certain amount of players are remaining on the graph. You can also select like specific quest, for example, the rescue mission one quest. So there's only like the actions that are for this quest are remaining on the graph. So this is what I said, like the action specific information. And for the player specific information like gender, so you can select like value 1 or value 2 here. So I also add one more function is like if we want to abstract other node into one dummy node. So if we put it yes, then all other actions will be abstracted into a dummy node. And you can see like how players move between this quest. Like they might started the quest and then they move other quests and they come to this quest again, something like this. So we can find like the strategy of players, how they complete this quest, whether they follow a certain path or they move between these actions. I saw a dummy node is all of the, yes. So this dummy node represents all of the other nodes. So we just have a one node to represent the others. So for example, for this quest, you can see like they move around and there's no specific trace. But if we put to another one like mutant 11, yes, if we put it this one, we'll see like this for this quest, like player just follow this quest. So as long as they start the quest, most of the player just follow the trees, completing the quest before they left. So this is a basic interface. Like it also have details telling you how many players, how many nodes and edges. So moving to our first feature, which is a segmentation feature. There are like two different kind of segmentation. I have introduced the metadata one and the behavioral one. So for the metadata one, similar to actually the previous filter you see before, we segment the players based on their attribute. So this graph is we call it a difference graph, which we color coded based on how many players in these two different groups. So red represents the first group and the green represents the second group. And the saturation represents like the percentage of the group of player. So this is still under development, and we are still figuring out like how this difference graph can help analysts or users to understand player experience. So I will move to this like separate one. Maybe this is more clear and self-explained to people. So from here, actually, you can see if we change the gender to expertise, for example, it can give you a more insight is that the expertise 4, which is self-reported like as a pro players, you can see like they follow a pretty certain path within the first several quests, especially for the first several 3. You can see like for the expertise 1 player, it's a little bit complicated. like there's no certain path. If you can see one like from the talk to Paul started complete this quest, and they move to the red problem start, and most of them move just directly to the third one without completing the second one. But for the expertise 4, which is pro players, they have the ability to follow this quest and finish this request in the order of their receive it. So in this way, we could assume that the segmentation can help users to understand player experience by giving their subgroups, segment players into subgroups. So this is metadata segmentation. So for the behavioral one, is like you can select select the node or edges in the graph, and then segment players based on your selection. So for example, if we select this edge from the red problem started to the understanding started, we select it. And for the second one, we select start and kill the red. So if we generate the graph based on this segmentation, we'll see like the 2 different graphs based on your selections. And there are also like different logic combination of your selection. You can select all selected, you can select any, and you can select none, which means that you can select multiple edges here. For example, you can select this one, this one, this one. So if in this one, like you select 2 edges and 2 nodes, and you can select any, the all option here means that all players who visit all of the 4 elements, and any and none, which is pretty self-explanatory, I would say. Yeah, so this is the selection part. And for the result, you can see like we would like to add a graph manipulation here for similar you see in the original one to help figuring out like less important nodes or edges. So what we want to see here is that for players who have who are divided based on this, like the red problem started to red problem kill red, which means that they follow the second quest, red problem. You can see like they also pretty follow the rescue mission. If you remember the original one, in the rescue mission, like players move in and out with this quest. But if we divided player based on a certain behavior, we can see like actually these players, there are actually 17 players in this group. They pretty follow the pattern as well. Like as long as they started 12 players, most of them are finished the quest before they leave, most players leave the quest until they finish it, until there's like only 1 player leave in the midway. But for this group, like they start the red problem and then they went to the understanding quest. They moving out pretty often, more often than these players. So this is another, I would say, a strategy detection approach through the behavioral segmentation based on the patterns you select from the player journey map, and then you segment players based on these patterns. You'll find strategies that are not originally obvious in the original player journey map. So yes, so this is the segmentation part. And one more thing is that on the bottom, there will be like different distribution of the demographic or metadata, like the player specific information distribution based on your behavioral segmentation. So you can see like how many, for example, the expertise 3, 1, or 4 within these 2 groups. So you can see here, like for the pro players, which is value 4, 4 of them falls into the second group, which follow the pattern, and only 1 of them are in the first group, like they move between the quest. Yes, so this is a segmentation part we implemented. We believe that this feature can help us get rid of messy player journey maps and detect or identify player strategy. Okay, so the second feature is re-abstraction. So I think if for understanding, similarly for understanding player strategies, like their granular actions, for example, in the between, like they kill a rat, they complete a quest, something like that. They are also like a high-level strategic concept. For example, they might complete mission 1, complete mission 2, and they sometimes, if they complete some missions, it's a good player, sometimes it's a bad player or something like that. Well, we will not say the bad player, of course, it's maybe less good or less expertise player. So this is a re-abstraction idea that we can abstract low-level or granular actions into high-level concept. So we define a concept map. This is a manually approach, like you create your own concept map and then you re-abstract the graph or player journey map into a high-level player journey map. So the concept map here is a tree structure visualization revealing the relationship between low-level actions and the high-level concepts. And the motivation of this idea is that we want to embed like analyst knowledge into player journey maps so that only high-level concepts based on the analyst knowledge are visualized in the graph. So the root node is automatically generated as a default node, and the level of abstraction is defined based on like degree of actions or concept. So in this graph, we can see like the first level of abstraction is a less good player or very good player, and the second level is a complete mission 1, complete mission 2, and the third level of abstraction is granular actions. So for this feature, I haven't implemented in a current one you are seeing before. It's we call it a high fidelity prototype. I have it before implemented in we call it like low fidelity that we used before. So here's a video. I will mute the video and I will explain it to you. So here, like you can see, you can select like how many actions you want to abstract. How many actions you want to abstract. And there are also different logic combinations, and or. If it's and, it means that this high-level concept is achieved only when all of the sub-level like connected low-level action are achieved. And or concept is like any of the low-level action achieved makes a high-level concept achieved. So you can select like, maybe you can select like 1 or 2 or 3. You can also naming your new actions as well. Because it's a manually approach, so you need to define this layer by layer. So in this one, we will have an example of 2. You can see like mission 1, and then you generate it here is a first part. And then you have another one, it's a red problem, like you said, it's mission 2. It will have like this. And similarly, they have a mission good player, and similarly to what I showed, like the less good player based on the quest 3. And after you construct this concept map, of course, you can save it and in the system, and you can specify each actions or each concept like level of abstraction. So for example, here you can see the quest understanding, complete, and stand is actually on the second level of abstraction, but you can change the configuration here. Although the visualization shows it's still on the second, but the actual concept is on the third one. So I think maybe in the next prototype, we will figure it out, like how to show it consistently. So after that, after you construct this concept map, you can see or inspect the original journey map into this 3 level. So for the third level, you can see like only this, let's say 7 granular actions are remaining in the graph. And if you change it to 2, you can see only like the second level, like mission 1, mission 2 here. And if you go to the first one, like good player or less good player, you can see like this. So this is an idea of the yes, here. You can see here is the idea of re-abstraction re-abstracting actions into different level of concept, which we think that this is a good way for users to analyze players' experience in different level of abstraction, both granular action and strategic level of abstraction. So there is another one is of course is through algorithms. This is still ongoing work with Johanna using the Guildwall dataset. So there are like two approaches. The motivation here is also like find popular or important sequences or patterns through algorithm, because sometimes building the concept map is pretty how to say that exhausted. So maybe using some algorithm telling you, okay, here is a very popular sequence, can help you to find or re-abstract a player journey map. So we implement this based on the probability. So there are like two approach, like one is a naive one and the second one is a conditional one. This probability in another way is also a kind of sequence frequency. So we are most calculate the probability based on their frequency. So for example, in the naive approach, the probability of a sequence is based on the accuracy of the sequence x n is divided by the sum of occurrence of all sequences start with x0 with the length of n. And then there's an average probability of sequence in length n is calculated based by the sum of all probability divided by the number of sequences in length n. So this average is used for calculate line. You will see it in the future. You'll see it later to compare the distance between a sequence with the average. You'll find like what the popular one and what the less popular one. So the conditional approach is based on the conditional probability. So if is a sequence from x1, x2, blah blah to xn, and the calculation will be like this. And for each conditional probability, it calculates based on the occurrence of the sequence, this sequence divided by the sum of all occurrence of all sequences starting with the preceding length, a certain length of a sequence. And similarly, we also have an average probability here. I don't think I want to explain this probability too much because this equation is a little bit hard to explain it in detail. I'm sorry. I feel like I just lost my language to explain this equation, but it's just a simple, although it looks complicated, but it's really simple calculation of the probability of the sequence.
Can I ask a quick question from my quick interpretation of that? It's the probability of head given rest of list, right? It's not the probability of the bigram.
Yes, so, for the conditional one, it's probability of head given probability of the last one given the preceding ones.
To a certain context window length, presumably.
Yeah, of course, you can define this K based on like how many preceding actions you want to use to calculate the conditional probability. Yeah. Yes, so this is a re-abstraction approach through algorithms. So in the system, we'll use the Guildwall data for this. So here is the Guildwall data, the Guildwall player journey map we saw before. And if we come to here, if we use a naive approach and we calculate the average line based on the mean or median we can choose, and you define this is a lowest sequence appearance, which means that, for example, if you define the 3, so any sequence that appears less than 3 times will be automatically deleted in during the calculation because it's really less popular that you might want to use. You might not want to use. You can also select the starting scales. Here we just use all maybe, and if we click generate one, you can see this graph. So the line here is the average value of the probability of sequences. And then the node here, each node represents one sequence. And this table gives you the distance between the sequence and the average value. And then based on this one, you can see like, we can have a table of rank, and then you can select like which one you want to see. So I think, I don't know, Johannes, you have noticed it or not, I have implemented the simplified and the show all functionality here. You can see, for example, this two sequence, actually the second sequence is a subsequence of the first one. So if we want to remove all of this kind of subsequence, we can just show simplified version, and then only the sequence that happened the first time will show here. So it's better for analysts to analyze this. And you can show or show simplified. And then after you see this, actually, you can select which sequence you want to abstract, and then you generate it here. I think it might be a problem. Yes. Here's actually one thing I need to abstract. I need to figure it out. I need to change the configuration. So if I change it to this, so this make it work.
The perils of live demos.
Yeah, this is, I should.
Impressive that a single line of code could fix it.
Yeah. Okay, so now it has a, if I change it to 50 and okay. Yeah, so it's a similar thing before. I know it's a easy password. Okay, so let's come to here. We do the same thing like 3, we select actions, and if we generate one here, you can see actually there's one new node here, and then it has abstracted into the new node. So after you need to click this generate after this re-abstraction, because all of the nodes or the appearance of node have been changed. So you can see you may abstract another one. So now I assume you will see 2 somewhere.
I think you picked the same one again.
Oh yeah, right. Oh yeah, I might pick the same one. That's true. What is?
No, I think you didn't pick the same one, but you picked the one that's including the combo already. So you're just re-abstracting that a level higher.
Oh, just making one giant combo node.
Oh.
So it's just like the the upper combo includes the lower combo. So you have to pick something that
Yes, that's
include
true.
a combo.
Yes.
I guess.
I think maybe. Oh, okay. Yes, I think this is let's see whether it works for this one. Yeah, you can see
it's right there.
Yes, so it's like a reiteration of the re-abstraction thing, and then you will have some new abstracted nodes here for analysts to understand how they play the game. So the reason why I changed the code debugging mode is because this is a new generated image. So if we set debug is true, it will automatically refresh after you have a new asset in the data set. So I need to make it like disable that functionality. Like whenever I put new things there, it will not automatically refresh. Okay, so this is a feature that I have for that we have for re-abstracting players' behavior from low-level granular actions to high-level strategic concept. And we are still working on this, no matter the applications, what actually this can help analysts to find, and also the studies. We are also designing study for this feature to see like how, whether this, no matter the manually approach or the algorithmic approach, can actually help useful for analysts to understand player experience. Okay, so these are the abstraction part actually. So after this, there will be one more feature is this is just a the feature in the very beginning stage. We call it a prescriptive analysis. So the motivation of this one is allow designers to test their ideas. So considering this situation, like there's a quest and there's 3 different ways of completing this quest. And what if we remove one of them? For example, this one might be you find a key, you open the box. And the C might be you just break the box. And the D is might be you just skip the box and get something later. So what if we remove the key? Will more players complete the quest, or maybe less player? Or like we can see, like if more player will just go to break the box, or they will skip it, for example. So in this way, we have a prescriptive analysis tag here. So for example, we will choose the quest rescue mission. We update the original graph, so it will show here. So here we can see like there's actually players who found the silvers, looking for silvers, and then they give silvers to bikers, and then they free prisoner and then complete. So there are different steps. I think this might not be a good example, but we can see a slight insight from it, because the problem is that most players, like 13 players, they just quit the mission. So if, for example, if we delete, there are actually 2 kind of delete here. One is a normal delete and one is a prescript delete. So for the normal deletion, we just delete the node, and in the data set, the player just go into its next action. So there will be no adjustment of the data set. It just simply delete that node, remove that node from player sequences. So you can see here, if we remove the looking for silvers for players, if you remember, for players who come from the start looking for silvers and found silvers, now this player are just go directly to found silvers from the start. So this is a simply deletion. It's a simple deletion that it will not change anything of the structure. You can see like how players played even when you remove one of them. So for the prescriptive delete, it will show like only 2 nodes are left, which means that if you don't have that looking for silver step, no one will complete this at all. This is an essential step. If we change it to another one, for example, the found silvers, we can see there's still some players who can complete the missions, which is they have the looking for silvers request, and they just didn't looking for silvers, but simply free the prisoner. So this means that found silver is not the required step to complete this mission. And if you remove that, of course, like more players will be just leave the quest before they complete, because in the original one, most players actually leave from here for these 3 edges. We can see this 13, 8, and 13. So if we remove this 8, it will divide the players, like these players, equally to these 2 edges. So this is also a probability approach. I would say ideas to redistribute the players based on the current data set. So yes, so I think, or we think that this is also another features that can help designers to test their ideas, because they can put their data set in there, and then we remove some node, and we see like how players will behave after this element got removal. So yes, I think that's most of the system, first of all, and thank you very much for listening. And I would like to see we are still looking for some collaborations, case studies, or anything that if you have a data set and you want to analyze your data set from a process perspective, feel free to contact me and we would like to collaborate. And also if you have anything in your mind that you think like to understand player experience through a process perspective, if you think this, for example, one feature is important to do this, please also contact me and we can have a discussion about it. Yeah, and I think that's all for today. And I would like to see if any problems or any questions.
Sounds good. Thank you very much. That was super cool. Are there any questions in the audience? I have many, and will probably follow up myself. Go ahead.
Maybe just a quick one. If you go just, oh no, I think it was not one slide back, but if you can go back to the browser, you just said that it's a good idea now with the prescriptive delete, which is new. It looks very, very helpful that people can delete single actions and see in the end if something is still completable or not. Isn't that a little bit the other way around? Like if you want to see what actions are actually necessary to complete the quest, wouldn't that be or wouldn't that be also interesting or helpful if you say my goal is rescue mission completed? In that case, now inspect, tell me what kind of nodes can I delete so that people are still being able to get there, or which are so necessary that there is no path anymore. So that would, like if you do that iteratively over all the other nodes that might lead to that in the end, you could actually answer that question without like trying and erroring on every single question, on every single node. You know what I mean?
Yes, I think if I understand your question correctly, like you want to see, like for example, if you click this node, it will tell you like what the required preceding node for this node, right?
Yeah, in principle, it could tell you what are actually required nodes and what not. I mean, I think that's a question that you opened with, that game designers would want to see. Is this node important or not? Is this node important or not? And so on and so forth. But in principle, you could do this all in one step if you say, okay, this is the goal node. Now tell me all that are important and that are not, right? But just maybe just one quick addition. But yeah, I mean, I know of the system, so I don't have that many questions.
Yeah, of course. Yeah,
I could actually see that kind of being depending on the use case of the analysis. And I'd actually be kind of curious to see in a user study like what people envision is this. But like I like a project I've seen before where like we found some bug in an educational game, and it's like, well, now we want to remove like these 3 levels, and it's like, what's going to happen if we do that? Like that's what I'm seeing this prescriptive delete being for. But I could also see trying to do the other way around of like, if for example we had this is kind of probably abstracting beyond what the thing can currently do, but if there was an event that was like you passed the post test, what's the necessary branches to go to that? Like that becomes a learning progression from an educational standpoint, and being able to work backwards. That could be kind of interesting.
Yes, I think for this feature, that's why I said it's a very beginning one, because first of all, we haven't found a suitable data set for this, because the original idea was like, if we remove one of them, like how players distribute to others, other approach. So we assume that for example, if we remove found silver or looking for silver, there will be some players complete, there will some player left. But when we actually delete it, we find that there are few players could complete. So it's only like 4 here, but originally there will be 9. So actually delete this one, cause some players quit the quest instead of completing one. So our idea is that we delete some complicated step, which means like it's more players went to the completion, but actually it's not, because more players, there's an edge from the start to the end, which called the distribution, like more players, or some players moving from this one. So
Nice.
yeah, I think like if there's some data sets that have multiple approach and not so many players quit during before they start, maybe this can help you like how redistribute the players through multiple ways. And of course, like what Johanna said, and it's also a good idea, is that maybe we can select one node and see what the important preceding actions for this node, so that explain like how players reach out to this node. So that's also an original idea, one of the original idea we have, but we haven't got it work yet. Yeah,
Sure.
that is under development feature as well.
Can I just clarify a question about how that process works? So essentially that rescue mission has 3 out edges, and you
Yes.
want to delete rescue mission found silver.
Yes.
And so the way it works is you just take all the player probability mass that's on that arrow and evenly distribute it among all the remaining arrows out from its preceding node, essentially.
Yeah. That's
Okay.
it. Yeah.
So you're essentially making the assumption that if you make it impossible to do one of these actions, players will evenly distribute across the others.
Yeah.
Which
Yeah,
which may or may not be true. And then also that they won't discover some other as yet unmodeled node.
Yeah, that's also true. Actually, I have a discussion before, one discussion before happening is that, for example, if you delete a very complicated one, actually, like for players who have this complicated step, maybe they already know the easy step. So all of this complicated that should follow to an easy one instead of quit one. So
Right.
this is another discussion happening, that we might allow users to define the distribution manually. Right. After they delete one. For example, for this one, like if they delete found silver, it's really, I mean, I know the game, so I know like found silver is not easy. So this is actually a difficult one. So for these 8 players here, actually they are all able to get to this one instead of the quit one. So
well, it's also, if you look at the topology of this particular graph, you have some information coming out from that node on how many did just quit.
You mean
right?
For this, right?
Yeah, like you have that bar, and then you do have some knowledge on how many actually went to the quest rescue mission looking for silver.
Yes.
Like you could forward cast as well as backcast to kind of figure out.
Oh, you mean
what makes sense to make that kind of assumption, assuming it eventually ends in some kind of cycle, or that all the nodes do land somewhere and they don't just like tree out.
Yeah, this is another idea as well. Instead of using the backward, but using the forward. But
if you do have a, I don't like, it really depends on the topology of the game. Because if the game just like becomes a massive expansive tree, and then the forward reasoning makes no sense. But I think it'd also be interesting to try and think about some way of modeling like an as yet unmodeled node. Like, or an as yet unobserved node. Like maybe they find some other transition that isn't in the data set yet. Because if you change the game, maybe that would happen, and it's hard to tell.
Yeah, I think that's a reason why like it's still here and haven't got any progression yet. Because we found like it's a really like game specific feature. Like different games have a different configurations. For some games, it might work. For other game, it might not make sense, and it's also depend on analyst understanding of the game. So for sim game, maybe some analysts believe like this is the dominant trace, while for others they might think, oh no, this might not happen, this might not true. So yeah, this feature I think I would say is a serious potential there, but we might need to think it more carefully. Yes.
Sure. Morgan.
Hi. I have a basic question. So, and I feel like we're kind of talking around my question, so I'm sorry if I'm just missing it, but what makes a good candidate for a game for this tool? So for example, does like every player have to have like equal opportunity to get, or to open every single quest, does there need to be like some sort of linear path? Like what if opening quest 3 like closes opportunities that another player who like went 1, 2, 3 like could see? Like, is that something that you just would find from looking at, like the analyst would find from looking at the graph, or are there specific games that you're looking at specifically? Yeah, that's my question.
Okay, so the question would be like whether data would be suitable for this system or to suitable for to be analyzed through this perspective.
Yeah, are there like, I feel like I'm maybe was missing like the very beginning of the talk, like what are the, and sorry, I'm not familiar with the games that you mentioned or that you are exploring. So what makes a good game for?
Yeah, I would say like from my understanding, I would say like there's no specific type of game or specific genre of games. So as long as a game is processed, so players finish or player play this game within different steps. For example, first do this, next do this, next do this. So as long as they play in a stepwise style, it could be analyzed through this system. Because this is like a process visualization. If we go back to its origin, like as long as there's a process exists in the game. So for example, you might have some optimized process. You might have some other like player might scattered around. It's all could be analyzed. So for this one is an RPG game. So RPG game. So this one is an RPG game. So I would say like any RPG game can be analyzed through this system. For Guild Wars is an online MMORPG, so this is another one. For actually, you can see here, there's another 2 tags that are still under development, is a Sky Children and Slay the Spire. So they are all like from the multiple games. So as long as, I think it depends on the goal of the analyst. So what's the analyst want to obtain from the data? So if you want to find out like what's a popular action or something like this, it can be done through a statistical analysis, which can be done in that way. If you want to understand players in a process, like what the order of their action, like what the popular patterns, what the dominant strategies, then I think this process perspective might be a good option for analyze.
Okay,
Hope I answered your question.
Yeah, you did. I was just thinking about the game that I've been working on for the last couple of years. Like it's a strategy simulator visual novel where you get to open conversations with, you open a quest and then you look around the community and open other conversations. But I'm thinking like, okay, it's called Bloomwood Stories. I'm like, is Bloomwood a good candidate for your tool? And I think we're close, but because when you open a conversation, you really can't leave that conversation, like that means that it really wouldn't be a good candidate.
I disagree. I think it would be a great candidate.
Okay.
I think, well, so can I offer a potentially different way of answering the question, which maybe is helpful, Jimmy? I think it's less about the structure of the game itself and more about the structure of how you abstract your data. And that there has to be some kind of, there has to be the ability to fall on common structure. So like if you imagine if you were applying this to say a game like Minecraft, if your actions were like punched tree at like X10, Y12, Z, whatever, like the random generation of the map makes it so unlikely that those things reoccur in a way that would create any kind of useful graph. But if it's just punch tree, that's a much more useful abstraction that would start to produce common structure. And so I think it's less so how the game is structured and more in how the data is encoded from the game. And that there would be ways to translate the encoding in a way that would probably support this process.
If I can add to that too, the data, and I mean, I don't know the game, the Bloom game at all, but it influences your interpretation of your outcomes too. So, you know, depending on what you're going to do, did they have the choice to leave? No. So that does influence our interpretation of that behavior to an extent, but maybe doesn't necessarily make the game an ideal candidate for this approach too. Just adds a nuance.
Seems like
Yeah.
it's just a matter of what you define a node as, like what
Mhm.
you're starting with there, and that could be any number of things. Like I could imagine running some of a more complicated game through this just to analyze tech trees, you know, and have that, you know, so upgrades would be the nodes, and that being really separate from which missions or levels they complete in which order.
And I think what's really cool about this system, just to say, Jimmy, your work is awesome, is that abstraction system lets you go from that really, really low level abstraction to a graph that like makes more sense or might be more useful to you. And I think that's like, to me, like the most valuable feature of this thing.
Oh, really? I would like to make a collaboration there so we can have work on the abstraction. Yeah. So our original idea for the abstraction is like, because sometimes the analyst doesn't know the exact level of abstraction they want to analyze. So they might want to test, for example, what if they abstract this? What if we abstract that?
Mm-hmm.
So the manually approach allows this happening, like, so they can play around with different level to see which level is make more sense. Another reason is that it can explain like the idea of the analyst if the analyst want to express this idea to others. For example, sometimes they need to build a insightful visualization or instinct visualization for others to know what this analyst really want to see. So this abstraction also make that happen, I would say. Yeah. Yeah.
So I want to be conscious for coming up on time, just for anybody that needs to leave. But I at least don't have to leave, so we can continue talking if you want to. I don't know what Jimmy's availability is, but just want to call that out for people that want to be conscious of the clock.
Oh, I see. Oh, thank you very much, David, for the data set.
I have a really quick question, and then I gotta bounce. The Slay the Spire data set, where is that something you generated, or is that something that's, because I love Slay the Spire. That's my.
Oh, really? Actually, we are still trying to figure out like a insight. So I can show a little bit here. So all data so we divided the data based on different there's one mode called Ascension mode. So I'm not a Slay the Spire player. I only know a basic of that game. So there's an Ascension mode and a different how do you call it, character or profession, like Ironclad, something like that. Yeah, so like we put the card selection here. So it's have a like uppercut, skip, headbutt, something like this. So you can see here is a very cluttered one because it's a large data set happening for the whole month. Actually, this is only one day. So this is happening only one day. Yes, I don't know whether you know it, but the Discord released a certain amount of data within a certain amount of days. So for each day, it will be about, I think, 1 gigabyte or 2 gigabytes, several gigabytes. Yeah, so it's have a data set like that. So we are working on understanding this game. So we're currently working on a graduate student. So they are working on a abstraction part of the Slay the Spire, and see.
Sorry, may I ask a quick question? Is that cards that have been chosen and added to the deck, or is it cards that have been played?
Card chosen to the deck.
Okay, because
Yes.
that's two different stories.
Yes.
Because with the playing, you'd be so heavily dependent on the deal and the draw.
Yeah, I mean, I think
but you
you
still
could
have a
also
little bit
think
in the
better.
choosing, right? The cards are not deterministically provided, or are they in this particular mode?
No.
Well, I mean, in the deck too, the probabilities are relatively easy to assume on the draws too. So
I would also throw in there that it's going to be pretty interesting because, like, based off the seed too, you're able to, like, I would be really interested to see, like, oh, what pathing is chosen for cards and otherwise based off of a specific seed.
There's also like
every
navigating the map
run of Slay the Spire has a set seed for it. Yeah.
So with the same seeds, they will have the same option.
Exactly.
It should.
Oh, really? Okay, that's good.
Is that in the data set?
Yes, I think the seed is in the
The
data
seed is in the data set? Okay.
Yes.
Because
Oh,
I could
that's
see
right,
if they
yeah.
have like a challenge mode weekly or whatever, it might be everybody plays the same seed or something like that. I haven't played the game in a long time. I don't remember if that's a thing, but
They do have a challenge mode, the
Yeah.
daily climb or whatever.
so if this is from that, then it probably does have a consistent seed structure, which actually
That's
then it's kind of surprising that the graph is so messy if it all is from this. But could also just be that it's huge. How many players are in this?
Here is 100.
100?
Yes.
Cool.
Yes, there are 100 normal ironclad players. So if for the defect, I think it's only 56. So they're different styles. So I don't know whether it's worked. It might take some time.
Because it's the whole data set.
Yeah, it's a whole data set for 1 day. So it's only like one. So there are like total 700 players. So no surprisingly, I would say the skip is the most visited one. So it's like 400, almost 500 and 2,000 visits.
This is such a great topic to get into. I'm struck by, and it's probably obvious, but when someone brings a tool to this, it's a different kind of conversation than an analysis or a process. And it really makes me wonder if you'd be interested in doing more of a workshop style thing where instead of 60 minutes, we give ourselves a lot more than that. And, you kind of share the tool or let some people play with it, or let us interactively play with it through you to say, hey, what happens if you click that? Or, and do something like that. Because I think when we're dealing with tools, there's just a lot richer of a kind of interaction that is natural.
Mm-hmm.
So why don't we work on that? Maybe pick a date for a workshop. I, for one, would sign up immediately, just to have some time to play with this more. So really good work. I think this could really benefit a lot of researchers.
And all you need for this is a CSV file that's like formatted in the shape of the ones you were showing at the beginning?
Yes.
I would really like to stick some of our data sets in here and play with it. It's like we did about 20% of this work and built a tool that we could use to explore node-based interactions. But seeing just some of your thinking around filtering and, it's like everything, you just took it farther than we did by a long shot.
Mm-hmm.
We've got whiteboard sketches of part of these things. So it's kind of neat to fast forward into the future and to see the prototypes that we didn't have to make.
Mm-hmm. And Morgan, I do think this would be valuable to look at Bloomwood in this way. It might be an interestingly, it might have some weird clustering in the graph because of the structure, but I think it would be really helpful.
I'd love to, just offer here too, is I'd love to do a workshop around it. And then when it's ready, and maybe ready means that you delete anything that isn't reliable or stable and you leave everything that's like 80% or more stable. I wonder if it's the kind of tool you'd be willing to share with folks on the Open Game Data site with some more samples, because I just think people would really enjoy playing with this.
Yeah, sure. I think it's currently part of it is online. So for example, the basic one and the segmentation one is pretty matured. We have put it online. Yeah. For others, we are still working on that. So it's still there. But yeah. I think this might be a decision made by Magy. So I need to consult Magy for about that.
I know from experience, I just had a lot of, it was a lot of fun, and it really led to a lot of great scholarship to share some of our tools in development with people before they were ready for prime time, but they were ready for other researchers that are used to working with research tools. People are just more patient. Or there are certain people that are more patient, and I think you might be around them and it might help.
Yeah, definitely. I think is Magy's here?
Magy's not here right now, but we meet with her the same week that this happens. Dave and I on Mondays. So
yeah, definitely. So of course I can share the link in our Slack if after I got approved by Magy, of course. Yes.
Yeah, that'd be great.
Yes.
Yeah, let's play around with the idea of scheduling a workshop here in the near future.
Yeah, that's a good idea actually. I think we planned it, but for some reason I forgot. We just postponed it. Yeah, let's see when.
Well, thanks again for sharing. We'll see where to go from here. We've got Slack to coordinate, and sounds like we've got some next steps.
Yeah.
Yeah. Okay. Thank you, Luke. And yeah, the data set is in the Discord, and they shared it. I don't think it's regularly, but there's one data set in the Discord collecting data from I think 2020, 1 year of 2020. So if you wanna like that, I can share that with you.
It's a whole year?
No, I think it's only 3 months.
Okay, still. I mean,
But
that's
that 3 months is unable to get, honestly. Like,
Yeah,
I just cannot
that's-
download it. Or I only able to download it 1 day or 1 week.
Yeah, that's
Largely.
remarkable at all what it is.
Yes.
But so just for the formal recording of it all, next week, not next week, 2 weeks from now. So that would be January 31st. We'll have another session. I believe the plan for that one is Jose on a framework for assessment in games. That one's going to be more education flavored. And then we'll try to get the recording up from this session as soon as possible, a couple days probably. And then, yeah, Jimmy, if you want to share any data or links or anything, we can put them in the spreadsheet along with the calendar. And then if anybody's still here or anybody watching this recording, all 60 some of you, has a project that they want to share